presentation of this session is from Jacob, who's going to be telling us what's new in DataStreams.
Okay, welcome everybody. Sure, applause. Welcome. So I got a lot to talk about today. I'm going to try and go a little quick and get to the fun stuff. So I have to clarify a little bit on my talk because the title said stuff about type flexibility and parallelism. Those are very work in progress, and I've got other exciting things that have been going on, so I'm going to talk more about other stuff. This stuff is still cool and coming, but I'm going to focus less on it today. If you want to learn more about the type flexibility, there's a good discussion going on in the data channel in Slack and on the CSV repo, because that's where it mainly comes into play. When you're reading a CSV file and you run into different types, what's the strategy there? It's actually a pretty interesting problem that a lot of people take different approaches with. But today I want to talk about tables. So this is the greatest package you've never heard of. Woo! So a little background on DataStreams for those who don't know. So I created DataStreams because I was dealing with lots of different data formats, CSV files, feather files, database tables, and I wanted them all to talk to each other and not have to worry about writing a CSV to database streaming function and a feather file to database streaming function and a database to this, all those combinations, right? So I was like, hey, let's create one interface in the middle, sources implement it, syncs implement their side, and then they can all talk to each other automatically, and it's fast and great. So that's where DataStreams was born out of. Now, hopefully, a lot of you have been able to learn about the queryverse, or David Anthoff's set of packages, query operators, a bunch of similar file format files that born out of the link style. So lots of overlap, okay, with what DataStreams does, but separate and taking a slightly different approach. So David and I have been talking a lot recently because, hey, we're kind of doing similar things here. Can we join forces and make this all great, for users so that there's kind of a unified, coherent story here? And the birth child here is tables. So what is tables? It's a set of interfaces that describe table types. Andy Ferris just gave a great talk on using stuff that's built into base, which is great, and I love that approach. But there's also this idea of, given an arbitrary tabular data structure or file format or whatever, how can we create one single common interface that other packages and things can use to then make them all talk to each other in a reasonable way? Because there's lots of advantages for these different formats. Okay, there's advantages, different indexing styles or type stability, this or that, data frames. So there's purposes for all of them. It's not like we only need to have one table type, but we also want to make sure that all of these things talk with each other. And when I build stats models, like Dave is going to talk about, I can use any table type you want to apply formulas over your linear models. So in tables, the interfaces are: a table is any type that iterates rows with, that doesn't show up. That's supposed to be highlighted, the row part, because that's special. It's, man, the highlighting does not come through at all. That's funny. Okay. So a table is any type that iterates rows. Okay, so Andy first was talking about a collection of named tuples. We're abstracting that just a little bit, where we say it's any type that can iterate rows, with the row type being any type with fields accessible via get property. Okay, so named tuple is a row. Don't have to worry, it's already built in. That's how you access it. But the idea here is, for a data frame, you don't necessarily want to iterate named tuples, because then you're taking it from one place and you're materializing this whole extra named tuple object, and that's expensive. Okay, you're allocating with each iteration. Whereas data frames already has a built-in data frame row, which wraps a data frame and an integer, and it's just a view into the original row of the data. So it can iterate a data frame row, and that can be a lot more efficient. And as long as we can build the interface off of this row interface, then it all just works. Nothing's going to break, but we get to be a little bit more efficient. So the idea is there's going to be this function called tables.rows that will return the rows of a table type if it implements the interface. what you get back will be a row iterator, so you'll be able to access that thing by name, okay, of the table to get each individual value. Now, in addition to the basic interface, there's going to be optional methods that a table can also implement. This is kind of more where the DataStreams interface came from, okay? And that's to provide some additional optimizations in certain cases, okay? So one thing you can say is, my table produces cells. I don't just iterate rows, you can also access individual cells by themselves, okay? And that can allow some optimizations in cases where I don't necessarily want to iterate the entire row. What if I have a 20,000 column table thing, and materializing a 20,000 row at every iteration is expensive? Maybe I only want to allow you to access one cell at a time, okay? So you can say that your table produces cells. You can provide a get cell, okay, where you give it the row and the column and the type of the value to get out. And then there's also an optimization where you can say that my table produces entire columns at a time, okay? If you have a columnar format, then we can be able to get that entire column in one operation and then pass it on to other things. So that's the basic of the interfaces. Required, optional, but they can, if your table supports these, then it can lead to better optimizations in certain packages where they can use that. This is not totally final, okay? This is something that David Anthoff and I pretty much hashed out in about a 5-hour hack session the other day. It's pretty good. Like, we have it all in a package, and we're trying to iron it out as quickly as possible, but we feel like this pretty much gets us all the way there in terms of everything that we've been able to think of so far. So the goal here, kind of obvious, but it's to allow for a simpler interface that any file format or data structure or whatever can implement and hook in to all of these other great packages that uses the interface. So DataStreams, Query Reverse, lots of the plotting packages, they all can use these stats models to do cool things with your table types, okay? And it will all just hook in automatically. We also have a goal of deduplicating packages. So there's a lot of overlap right now. There's CSV files and CSV and Feather files and Feather. The idea there is that we can unify them into single packages so that it's less confusing for users when you go, hey, I need to read a Feather file, where do I go? There'll just be one option, and it'll all just work because it's all providing the same interface anyway. And then obviously more efficient integrations. So I want to quickly show something else unrelated that's also cool, that's going to use the tables interface, okay? And this is new in DataStreams. So this is functionality in DataStreams where you can actually query a DataStream source, okay, soon to be tables, whatever implements the tables interface, directly from DataStreams. And what it's doing is I have a full query planner built into DataStreams. So it'll take the combination of all the operations you're doing, plan a query, and then execute. So let's see what that looks like. Here we have DataStreams and my little table here. So my table is just a name tuple of columns, and I'm going to stream it into a row table. So in this first pass, I'm just selecting all of the columns. So it's a select star, if you will, in SQL speak. And I've actually turned on the query planner explain mode here, so you can actually see the code that gets generated. So it's iterating through each row, it's grabbing each cell, and then it's generating a name tuple that gets streamed to the output. And that's really cool. That's all generated and compiled. It's a planned query, and then it gets executed. We can see down here that we end up with an array of name tuples. So let's do something a little bit more involved. So here we're doing essentially select AB, filtering where A equals 2. So we're doing a select component, we're doing a filter component. So we begin streaming, we say get the first column, and then we're actually going to filter on that value. And hey, if we filter on that value, and it turns out that we need to filter that row out, we're actually going to skip the rest of that row. So we're getting some efficiencies there. And then we're going to stream the second value only if we passed the filter barrier there, and then we're going to stream all of that out as a named tuple to the output. And we're implementing our select statement here, right? Because we said select B and A from the input. So this is really cool. I really like this. I think it's pretty fun. You can get really crazy with stuff. So here we're doing like a select A, sum the C column, sum the D column as F. So we're creating a new F column. We're grouping by A, okay? So the syntax here is a little involved right now. So that's part of this whole integration process is I want to be able to hook into the query DSL. So you'd be able to write query style link, things that would actually get executed by the DataStreams query planner. So that's one of the grand goals in all of this. So let me see here. You don't need to see my Hangouts. So yeah, the plan here is to finish and register the tables package. We want to port existing table packages over to use that interface and implement the optional methods where possible, and then make sure that it's all integrated, clean, and performant through everything. So that's the plan. Thanks for listening. Excited to see what happens with data stuff in Julia. Any questions? Awesome.